Good day, folks. Welcome to my YouTube channel. So today we're going to look at the this question. This is June 2021. The IEB, the independent body. It's not part of CAPS, but it's relatable to CAPS. It says consider reaction A and B shown below again. Reaction A, we have a nitric acid and a potassium hydroxide, and gives you that. And reaction B, we have a nitric acid, which comes from this and reacts with the sodium carbonate and produces that. Now it says here, a 13 gram of impure sample, which is the potassium hydroxide, is initially dissolved in 200 cubic centimeter of 1.2 mole per dm3 nitric acid solution. The nitric acid axis was an axis. Now basically for that statement, it's this. Here's a 13 gram of the impure sample of potassium hydroxide. Simply it means that, guys, here we have the pure, which is the pure is the caustic potash, which is the potassium hydroxide, and we have the impurities, right? Okay, now it says here this impure sample was dissolved in 200 cubic centimeter of 1.2 of nitric acid. Here's the 200 cubic centimeter of the nitric acid with its concentration. And then what happened, this impure sample was poured here with a 200 cubic centimeter of the nitric acid. And then we are told in the statement the nitric acid, so when these two react, this potassium hydroxide, remember in this impure sample, it's only the pure part that will react with an acid, right? So when this potassium hydroxide with a nitric acid, right? This potassium hydroxide with a nitric acid react. This is a nitric acid, guys. This is the potassium hydroxide. Let me remove this. This is not sodium carbonate. This is the potassium hydroxide. So when this impure sample react with this nitric acid, so only the pure part, which is the KOH in it, besides the impurities that will react. And then now the excess in this 200, the volume of this is 200. So the excess in this 200, it's the nitric acid. That's what I've written that, right? But this excess, we do not know how much is it and what is the concentration. The concentration is not going to be the same with that because these two are mixed here. So the excess here, it's a what? It's the nitric acid. Now it says here, we do not even know how much of the potassium hydroxide reacted with the nitric acid. Remember, the pure react with an acid, but we do not know how much reacted with that. Now it says here 550 cubic centimeter of the resulting solution was then titrated to neutralization using 23.67 of a standard solution of 0.5 of sodium carbonate, right? Let's say the 50 cubic centimeter of this was titrated, right? So here in the burette we'll have the excess, and then the excess, what is an excess here? It's nitric acid, sorry. It's a nitric acid. It says 50 of the resulting solution was then titrated. So the resulting solution there, it's an excess. So the excess here, the 50 of an excess was taken to that. So here in the in the burette, we'll have the nitric acid there, and then it was titrated with the sodium carbonate. So here there's going to be a sodium carbonate, right? So it was there was a neutralization that occurred between the two. So they neutralize with this value, which is, this is a volume of what? This is a volume of an acid, which is the nitric acid, and this is a volume of the base, which is the sodium carbonate, and this is the concentration of the base. But we do not know how much was the concentration of this nitric acid, which is the one that we have taken here, which is an excess that we titrated here. We do not know. So, but what we know, they have been titrated. This excess has been titrated with the sodium carbonate. So if we can first find the concentration of this acid, because its volume we know, it's 50, and the volume of the base that it neutralized we know, and the concentration of the base we know, but we do not know the concentration of this excess, right? So what we can do, we can calculate the concentration of an excess, but I'll do it in an easy way. I'll use this formula that says CAVA divided by CB times VB equal to NA divided by NB. So by doing that, I'm going to calculate the concentration of this acid that was titrated. So the concentration of an acid is the one that I want, and the volume of an acid is 50. And then the concentration of a base, it was 0, the concentration of a base, it was 0.85, which is that. And then the volume of a base, it was 23.67. Where do I get that? There, right? So the number of moles of an acid from this equation, we're in the titration, you must be careful, we're here in these two, so it's 2:1. It's an acid and a base, so it's 2:1 there. And then if you do your math there, you get your concentration. It's going to be 0.80478. Guys, you need to write the answer in full because we haven't reached the final answer yet. So what is this, guys? This is the concentration of the nitric acid in excess. The concentration of nitric acid in excess titrated. This is the excess that is titrated here. This is the concentration of this that was there, which is, this is the same concentration that is in excess there, right? So what do we need to do? Guys, I haven't even read the question. What was the question? Let's go back there. Now here, the question, it says determine the amount in moles of a nitric acid that was added in KOH. So we want the number of mole of this that was added with the KOH. This is the KOH, and this is the nitric acid where they were added here in this. So we want the number of moles of this, which is, this is the initial, right? We want the initial there. So before this, guys, just forget about this for a minute. So it's 5.1. Let me just write it here. It's 5.5.1. The number of moles of that, we use the formula that says C is equal to N over V, because we have the volume of the nitric acid, which is this, and the concentration. So the concentration is 1.2 and the volume is 200. You divide by 1000, so it's going to be 0.2. So the answer there is going to be when you it's going to be, the number of moles is going to be 0.24 mole. This is the initial. These are the number of moles, the initial, right? They didn't say that, but it's the initial. That's the initial of what? Of nitric acid, right? Guys, I'm going to skip these two questions, right? Let's go to 5.4.4. It says calculate the percentage period of KOH. So we wanted the percentage period of this. So in whatever that I've done, so we found the concentration of this. That was the first step of this answer. We find the concentration of this titrant here, which is the excess, which is here, the one that was put there. So what we can do now, this was an excess. We need to know how much was this KOH, this nitric acid, reacted with this. So what we can do, we can say using, guys, now that we have an excess, we need to know how much from the initial, which is the initial is this, and then we're going to minus the excess. It's going to tell us how much of this nitric acid reacted with this. So we're going to say now, the next thing we're going to say the concentration of nitric acid reacted with what? With KOH, right? That's what we're going to do now. So we're going to say concentration of nitric acid reacted is equal to concentration of nitric acid, which is the initial. That's why they ask us that. Initial minus the concentration of nitric acid excess. So if we minus the excess from the initial, so the initial is 0.80. Where was it? Yeah, here is it. 478 minus the no. I'm minusing the initial. What was there before? What was there before? It's 1 point. No, I'm kidding. Yeah, it's 1.2. The concentration of the initial, which is this. It's 1.2 minus 0.0800478. So our answer there, if you punch that in the calculator, is 39522 mole per dm3, right? This is the amount, this is the concentration of the nitric acid, right, reacted with the potassium hydroxide, which is the pure. Now that we know, we can do, we can just from that we have the concentration, but now that we know, we can change this concentration now into number of moles. Number of moles of reacted, we can say C is equal to, okay, let me write it. And we'll say number of moles of what? Of nitric acid in 200 cubic centimeter. Remember, this excess was here in this 200, right? This excess was here in this 200. So we have to know, ever since we got this concentration, but if I want the number of moles of this, I have to know in this volume, because this was found there. So in 200, so what I'm going to say there, I'm going to say C is equal to N over V. C is equal to N over V. The concentration is 0.39522, and the number of moles that I want, which is the number of moles reacted, and we do it in the total volume, and this is the concentration of what? Reacted, right? So number of moles reacted, and then the total volume. The volume, it was what? 200, but the 200 to divide by 1000, so it's going to be 0.2. So if you do that, you cross multiply, we get the number of moles reacted. It's a number of moles of what? Of a nitric acid reacted, which is going to be, if you punch that in the calculator, it will be 0.079044 mole. And then from that, what we can do, we have the number of moles of reacted, we can do the mole ratio. We know the nitric acid, while it was here, the nitric acid, when it was added here with this pure, it reacted, the amount of nitric acid reacted, it was this, right? But now, in order for us to know how much was the KOH reacted with the nitric acid, we can just do the mole ratio. So now we wanted the amount of what? Of KOH reacted, or what? Or pure, right? So what is pure is what reacted with the nitric acid, so we'll do the mole ratio. Nitric acid is to KOH, and the mole ratio from the equation is 1:1, right? 1:1, so it's going to be the same. It's 0.079044 is to 0.079044, right? So now we can change the number of moles of that. So we got that which is the pure part of the KOH, so we can change it into mass. Now we can say number of moles is equal to mass over molar mass. Let me write it proper. Number of moles is equal to mass over molar mass, and then is equal to 0.079044 equal to the molar mass of the KOH is 56, and then we cross multiply the mass there. It's going to be 4,426464, right? Grams. And then we go to a percentage purity. Now say percentage purity is equal to the mass of what? Pure divided by the mass of the impure, right? Multiplied by 100. And then the mass of the pure is this, which is the 4,426464 divided by what was the mass of the impure? It was 13. Where do we get the 13? The 13 is this. This is the mass of the impure. The mass of the impure sample, and then we multiply by 100. So the percentage purity there is going to be 34.05%, right? We answered this question, the percentage purity of KOH. If you don't understand it, guys, just repeat and repeat and repeat the video. Cheers, bye.